Is the mic working all right? Does not matter. I think I can speak loud enough. I read that script before you just read it. ChatGPT's first model came out in 2020. That is scary that a 5-year-old knows more about me than my parents do. Absolutely unbelievable. Anyway, thank you so much for coming here tonight. I'm here to talk about my second book, The Language of the Stars. If that's not giving astrology vibes right away, I don't know what does. It's not an astrology book, I promise. It was like, okay, one of my friends sent me this article that was like, literally from an astrology newsletter saying, involve the language of the stars to unlock more cosmic wonders in your life. And I was like, double whammy, oh my God. Okay, point is, it's not an astrology book. The point of The Language of the Stars, the general summary, is looking at some common themes that have occurred throughout the universe, throughout its history, over and over again, to the point where you could consider it a kind of language of nature. The point is that by looking at the patterns that have occurred in the universe, we can better understand our own origins, the evolution of life, the evolution of our solar system, and what unites us on a deeper level than nations, languages, races. What chemically or physically does all life have in common? Does everything in the universe have in common? That is the point of The Language of the Stars. It's not astrology, I promise. Astrology drives me crazy. You can blame my Scorpio rising for that. Anyway, point is, okay, the general gist, I'm gonna pose I should probably introduce myself first after that introduction. My name is Nathan Hellner-Mestelman. I'm the author of these two books. I gotta say, being a teenage author is kind of like weird at times because they take the author bio picture and then like 2 years later the book comes out. So by the time the book is out, you look at the picture and then you look at yourself in the mirror and I'm like, am I actually senile? Like, I don't know, like I just see those wrinkles in my forehead and then like this like infantile picture. I don't know. Anyway, there's a QR code if you'd like. I will be selling books outside in the foyer after this. So without further ado, let me pose you a question to begin this. Let's suppose you were tasked with texting a friend of yours. Texting a friend that you've actually never met in person before, but you know, you're gonna get along just fine. So you're gonna text them, you know, basic information like your home address or like a selfie of yourself, your height, some facts about where you live, some facts about yourself, maybe a little info about the device you're texting with, you know, decent things you talk to a friend about. The problem is that they're gonna ghost you for a while after you send the message. And you get the sense they're not exactly interested in a hangout given that they live 400 trillion kilometers away. This is the audacity of the problem that the Arecibo telescope was dealing with in 1974. So the problem is, if you are going to communicate with extraterrestrial life, what the heck are you going to both mutually understand? Let's invoke the language of the stars. Here's what we came up with in 1974. The Arecibo message. I say we as like a generic we because believe it or not, I was not even an idea back then, but that's fine. This is the Arecibo message in its plain binary form. It is just a long string of ones and zeros that was beamed into space at about 20 trillion radio watts, which is, for comparison, enough to make a semi-trailer truck explode if it were converted to pure energy. But anyway, they beamed this out into space to this globular cluster of about 20,000 stars, and in 35,000 years it will get there. And then if anyone's listening, 35,000 years later, we will get the reply. So yeah, teenagers in the crowd, if you thought your ghosting was bad, you ain't seen nothing. But this is just binary. Okay, so like, let's try to understand this. Could you understand this if you received this? I mean, here we have the numbers 1 to 10 in binary. Why binary? Base 2. So you count up 0, 1, 1, 0, 1, 1, 1, 0, 0, 1, 0, 1. So why binary? Because you can count in base 1, which is 1, 1, 1, 1, 1, 1, 1. It's giving Roman vibes, but anyways. Or there's binary, which is slightly more efficient, and it's also 2, which is the next number up from 1. This has shown up. Okay, the point is, binary was actually not invented with computers. A little backstory, binary was invented in the 1600s by Sir Gottfried Leibniz, which was kind of like the main adversary of Sir Isaac Newton. Binary code has been around as an efficient method of communication a lot longer than computers have been. And binary code has been created at least 3 different times by humans throughout history. So generalizing, if you extrapolate from that, binary might be sort of the universal counting system. But we're including the numbers 1 to 10 because, you know, we count in 10. We want to show that we count in 10. Then using those numbers, we have the atomic numbers of the elements hydrogen, nitrogen, carbon, oxygen, and phosphorus, which if you don't know are like the big 5 for life on Earth. That is the basis of our DNA. You cannot have life on Earth without these elements. And then if you take those numbers, elements, and you organize them into different groups, you get, well, very, very vaguely, the molecules that make up DNA. Adenine, thymine, cytosine, guanine, AGTC, the code of DNA, and then the structure of DNA. So like, with a baffling amount of, it's a stretch, the point is, but like if you take this with like, not just a grain, but like a dumpster truck of salt, this very vaguely paints out the human genome in binary code. And then of course we have a selfie of a human here, or a stick figure, and we have the person's height measured in a unit that I'll talk about later. And then we have the world population in binary as it was in 1974. And then we have the solar system, the sun, the big square at the top. And then we have 9 planets, because believe it or not, we still loved Pluto back in 1974. Pluto fans in the crowd tonight, yes. However, the 3rd planet is skewed off to the side because it's Earth and it's special, and that's where the message came from. And then of course, if you want to text the device you're texting with, that is a map of the Arecibo telescope. Again, with like a dumpster truck of salt. So, yeah, there's the Arecibo message. It was not until, what was it? The Pioneer probes were launched that we actually tried communicating in any method other than this. But point is, we have a lot more in common than just this. But to really think about what we might have in common with alien life on a deeper level, we need to look beyond just binary. We need to look beyond DNA. We need to look beyond weird selfies. The point is, we need to look into the fabric of the universe itself. We need to look at something called dark matter. Anyone heard of dark matter? Yeah. My God, you're spoiling everything. I should just get off the stage right now. Okay, point is, dark matter, for those of you who don't know, dark matter number 1, for those of you who don't know, is a substance that seems to be everywhere in the universe. It does not interact with normal matter at all. So it just passes through everything. It's passing through your body right now, same as the beer if you've had a drink tonight. And dark matter, the substance, is extremely massive, like 7 times heavier than all the normal matter in the universe combined. The only reason we know it exists, or are almost certain that it exists, is because it appears to be tossing galaxies and galaxy clusters around in ridiculous ways that those galaxies would not do on their own if they just had normal matter inside them. Dark matter, the beer, originated in 2011 at Hoyne Brewing Co. and weighs about 20,000 tons in terms of its net production. Anyway, point is, you might be wondering, okay, this is an astronomy talk, I promise. You might be wondering why the heck I'm bringing up beer in a talk about what we might have in common with life forms beyond this planet. The point is, beer has a very majestic backstory, and this is a perfect place to start when it comes to common features. Hear me out, okay? Dark matter beer, for those of you who've tried it, I'm 18, drinking age is 19. I did an experiment under the supervision of my supervisors, aka parents, that's fine. Dark matter beer has tinges of chocolate flavoring, and chocolate flavored alcoholic beverages go way back. So if we pull up a map of the world, let's take a brief history of time and other beer related herbs. And if we take a map of the world and we look at the origin of chocolate fermented alcoholic beverages, this takes us back to Mesoamerica, to a drink called socolatl, back in 1400 BCE. This is just fermented cacao beans raw. So this is kind of the earliest form of dark matter beer ever. However, if we look at beer, it has not just originated once. It originated, well, first of all, in Sumer about 10,000 years ago, called Caste. Then it originated 9,000 years ago in China, then 8,000 years ago in Egypt. It originated in the Indus Valley. It originated in Australia, in what's now called Russia. It originated even in the Incan civilization. Beer has originated over 35 different times over the course of human history with absolutely no contact between these respective civilizations. It just seems to be something that happens eventually. You let a culture of humans ferment long enough, and beer just happens. What the heck does this have to do with alien civilizations and things that might be shared in common between them? Well, probably not beer, but this gives us a starting point This is a really ridiculous example of a concept in biology called convergent evolution, which is just a fancy word for the same traits evolved multiple times coincidentally, with no relation between them. Even if they evolved in different places, in different circumstances, the same thing evolved. Beer is literally your #1 example of that. But it's not just beer. It's not just beer because if you dig up ancient relics, if you take a pickaxe and you go to ancient Sumer or ancient Egypt or ancient Greece and you just start ravaging through those ancient artifacts and looking for things, you will find yet another common thread between all these ancient civilizations. You will likely be arrested by UNESCO. With an excavation license, you may find yet another common thread. Now, with a legal excavation license, you may find that the number pi actually appears a pious number of times. Now, it was first discovered at around 3 different points in the same time in history, once in Egypt, once in Babylon, once in Sumer, because people, just being curious, wanted to know what the heck is the ratio between the diameter of a circle and the circumference. Turns out it's around 3.14. And then the Chinese discovered it, and then the Indus Valley discovered it, and then the Greeks discovered it, and then people just kept finding this. Like, pi has been independently discovered over 25 times across human history. It just has been encountered. People have been curious and wanted to know this number. And the strangest thing about it is, these people did not use the same counting system. The Babylonians used a base 60 counting system. That means 60 symbols before you add another decimal place. That means you count to 60 and then you add your, tens placeholder, but it's not tens, it's 60s. So they counted in 1s, 60s, and 3,600s. That is different. The Mayans used base 20, the early Sumerians used base 12, and then the Nagari system, which later got adapted into our base Latin system, used 10, which we're used to today. But there's nothing special about 10. It's just the one we use most often today. The point is, these cultures were a world apart, a practical universe apart. Their counting systems almost alien compared to each other, and yet they stumbled on this same number over 25 different times. It's almost like you could beam this into space in binary code in 1999, just in case someone out there has also discovered what the ratio of a circle's width to its diameter is. And that's what we did in Evpatoria in 1999. So this is a great place to start. Convergent evolution, in terms of knowledge or facts that we've encountered multiple times over human history. The recipe for beer and the number pi. 2 examples, it does not stop there. In fact, you can look at convergent evolution from a biological point of view, which, spoiler, is usually what it's referring to. It's not usually referring to beer, unfortunately, but if you take the tree of life, beginning at DNA, ending with all the 8.7 million species we see today, beginning, and we're just one of 8.7 million species who all share a common ancestor, whose name is Luca, by the way, the last universal common ancestor. I'll get to that a bit later. But the point is, we evolved our 4 legs or 4-limbed state along with most other creatures in kingdom Animalia, or mammals, tetrapods, from this one guy named Tiktaalik, a species of fish-descended amphibian about 400 million years ago. And from that fellow, we and all other modern mammals and animals today have 4 limbs. But because this was a fish-descended creature, and because biologists suck with taxonomy and have not come up with any defining boundaries between that creature and us today, that means we, fellow humans, are fish. Absolutely. No, literally. Okay, I did not think of that. You should be a comedian. The point is, okay, there was this article a while back that was new study shows that fish can recognize human faces, and I was I'm glad we can recognize human faces. It's been a long time coming, to be honest. Anyway, but the point is, these things evolving from one point throughout history is actually more the exception than the rule. If you look at wings have actually evolved 4 different times from 4 independent sources convergently throughout history. Once in bats, which are mammals, once in insects, which are arthropods, once in the dinosaurs, which later became the birds, and then once in the pterosaurs, which are kind of the distant unrelated cousins of the dinosaurs. No relation at all, but wings, because our planet has an atmosphere, and if that's a niche that life could fill, it probably will, and it did 4 different times. And we also have Echolocation, that evolved twice, once in bats, once in dolphins. Those are 60 million years apart, and yet they both evolved with the exact same trait. Then if we, like even brains, neurons evolved twice throughout history, almost guaranteed, and I'm going to talk about this a bit later. Once in comb jellies, like literally the blobs of the sea, and then once in animals. So even brains are not necessarily a one-off evolution on Earth. If you look at this really nifty kind of chemical reaction called C4 photosynthesis, which is something that a lot of plants today have cracked pretty well, that evolved 40 different times throughout history. Once I'm not even going to list them all, never mind. And then eyesight, just the sheer ability for cells to detect light and then communicate that to a brain, evolved 65 different times throughout history. Completely unrelated. So this is the sheer power of convergent evolution, in that even if you got this giant planet with billions of different niches in the environment, you can get the same traits evolving lots of times, just like beer, just like pie, these features. And so should we be astonished by this? Yeah, it's pretty awesome. But should we be surprised? Not necessarily. We live on a planet that has a dense atmosphere. And again, if that's a niche that life can fill, it will. We also happen to live on a planet around a star whose light wavelength peaks at green. And if you look at the color of plants these days, it's kind of given. It's given green. And so when you look at that, yeah, convergent evolution is amazing, but it's also not surprising given that life, even though it lives in a billion different niches, there are some common features between all of those. A star that peaks in green light, air, except for the ocean, which is why nothing flies down there. But anyway, but we can go even further than this, because even if we look at what life has in common on this one planet, we can go even further back and see what life could have in common across the universe. Because believe it or not, there are common traits across the universe too. How did the universe begin? Well, if you ask the question, where do babies come from? And you ask parents or astronomers, both will tell you the Big Bang. And if you... And if you look at the origin of the universe, you can see the same traits appearing multiple times. In fact, around 400,000 years after the Big Bang, this really popular element called hydrogen started appearing everywhere. So these little particles called quarks coalesced into protons and neutrons, and then those got together into hydrogen. And the cool thing about hydrogen is it does this really cool thing, and it emits this wavelength called the H1 line. So hydrogen, no matter where it is, no matter what state it's in, cold hydrogen, superheated, hot hydrogen, liquid hydrogen, metallic hydrogen, solid hydrogen, gaseous hydrogen, happy hydrogen, sad hydrogen, it doesn't matter. It's going to emit this radio wavelength of 21.106 centimeters, always emitting this hum of radio static. In fact, if you turn on your car radios and you tune it to 1,406 megahertz, which for the record is like way beyond what any car radio is designed to handle, so that's not going to work. But if yours is for some reason, if you had it designed by like the same company that made Vinyl Tap's amp go to 11 or something, then listen to the hydrogen H1 line. It's fine, fine cosmic jazz. But anyway, the point is, when we sent the Pioneer probes into space with a message from humanity designed by my man Carl Sagan, any Carl Sagan fans in the crowd? Yes! We used the base length measurement based on this wavelength just because of how popular or how common hydrogen is in the universe. It is the core element of everything, stars, planets, life. It's everywhere. And if any civilization's intelligent enough to have studied it, they're going to know about this wavelength, the H1 line. So if you try to decipher this, it might be a little more obvious what we're trying to get at here. We have the portraits of humans. Again, you don't need clothes on a cosmic stage where no one even knows what your species looks like. If you add clothes, they're going to think you just extrude fabric from the womb. I don't know. Anyway, yeah, for your terrestrial viewership, I've added sensors, but like, really? Anyway. So we have human figures, it's a portrait. We also have the solar system. Again, we still have Pluto because this is 1972, we're talking. And then the probe coming from the third planet. But then we also have these little guys, the hydrogen atoms, one flip or one emission of the wavelength. So this is meant to signify the hydrogen atom switching from its reverse, like it's switching between the two states that it emits this wavelength from. So that is basically both representing the time it takes to emit this one wavelength, which is about 7 nanoseconds, really, really fast. And it's also representing the distance between one peak of this wave and the next, which is 21.106 centimeters. So that is your universal yardstick in this message, because I mean they're not going to know what a meter or a foot is, or what imperial or metric is, or why the heck we fight over them so much. It's just going to be hydrogen. So then you also notice the height of humans is basically a dash dot dot dot, which is meant to signify the number 8 in binary code, which for the record is the height of the average human female in hydrogen units, which is still pretty true today, given that humans have not gotten a lot taller in the last 5 decades. But then basically the point of this was to show the average size of humans, because we didn't want to come across as Goliath-sized, you know, like Godzilla creatures, but we also didn't want to come across as 7-inch hobbits. So sense of scale, you know. You also might be wondering what this is. This is our first attempt at a cosmic home address return to sender message. I don't know, because you can't really use postal codes, you can't really use home addresses in space, but you can use dead corpses of exploded stars. This is like sending a message to your long-lost lover using the coordinates of the nearest graveyards. I do it all the time. What's weird about that? I don't know. Anyway, the point is, these are collapsed stars called pulsars. So when really massive stars collapse at the end of their lives, they crunch down, and then if it's too massive, it becomes a black hole. But if it's just right, it will crush down, and the protons and the electrons will be crushed into neutrons, and it will start spinning really, really fast. So fast that it will shoot 2 beams of charge or radiation out, one this way, and then it will just start spinning like a cosmic lighthouse, sweeping radiation throughout the galaxy. You cannot miss it if you see it. It's a telltale blink, blink, blink. And so if you take the nearest ones to the solar system, the most iconic ones in the galaxy, and you give their blinking period in units of hydrogen atom flip time, which is, it's pretty convoluted, but there's really no alternative, come to think of it. And then you put that on a map, and then you put the solar system right at the center, and you add the galactic core, or the center of the Milky Way, for reference. You've basically told people exactly how to find your home, for better or for worse. Anyway, so this is the most sophisticated message we had sent into space until this new message called Cosmic Call came out in 2023, but I'm not going to talk about it because it's so insanely complicated. You can feed that with your own curiosity later tonight if you want. This is just the basics of how to talk to aliens. I am not an expert on that. You should talk to Carl Sagan. Anyway, the point is, after hydrogen became a thing, we need to do a flashback to our good friend dark matter, not the beer, the cosmic substance. Because after this point, dark matter really started to set off a cascade of common features everywhere in the universe. About 100 million years after the Big Bang, hydrogen clouds started collapsing everywhere into the first stars. And they were massive. Like, these stars took on the party hard, die young mentality. The first stars ever, about 30 times wider than the sun, lasted about 1,000th as long, a few million years, burning as brightly as 30 million suns, and then bang, exploded in supernova explosions. And these explosions really went off all around the same time in cosmic history and laid the foundation for heavier elements like iron, like gold, platinum, uranium, silicon, all these things that are now making up the rocky planets of the universe today. Everything around you that you see that's heavier than iron, like the tin or the silver in my braces, were fused in the core of a star that exploded billions of years ago. There is no other place in the universe where it could have come from, because stars are generally pretty crappy furnaces when you come to think of it. They have to explode to really cook the heavier stuff. And then, suddenly, black holes became huge. Like, actually insanely massive. There's still not a solid theory as to how they got so freaking big. Like, that is 100 billion times more massive than the sun. And if you think about the fact that something that big appeared in just 13.8 short, brief billion years, it's weird how big they became. And so how did that happen? How did black holes become big enough to become the centers of galaxies, stirring up the chemistry that gave life the materials it needed to evolve? Well, by the time the first galaxies started appearing, by the way, these are all cartoons from the book, so if you want more of these are my cartoons. I will happily sign you a copy. But the stars, okay, the first stars in the universe, again, I said, really, really massive. We have, for scale, celestial buddy, the sun. Really happy guy here. If the sun were this big, the first stars in the universe that formed the centers of galaxies would be about as large as Victoria. So big that nothing has ever come close ever again in the history of the universe. In fact, they were so massive that black holes literally appeared at their centers and then cannibalized them from the inside out until they became supermassive black holes and stirred up kind of a mess, which later became our galaxy, filled with asteroids and heavy metals and planets, and then later Spotify and heavy metal. And the origin of our solar system was pretty run-of-the-mill average in the scheme of things. There were rocks crashing into each other. There was an asteroid hailstorm, which is thought to have delivered the oceans, actually. So if you looked at the forecast, it would be molten rocks, molten rocks, vapor, Mars-sized impact, bang, it's the... But the point is, this chemistry started mixing in the oceans, and in a very long, convoluted process, this star stuff, the dust of long-dead stars, eventually whisked itself up into things that we could consider to be alive. Again, there's your guy Luca, the last universal common ancestor, which evolved about 3.8 billion years ago, and because of how much we have in common with the rest of the universe at this point, it's literally just basic star guts that have been strewn into space. That stuff is everywhere. And if that can stir itself into the chemistry needed to produce life, it really gets you thinking, has this stuff happened elsewhere in the universe? I mean, just look at the origin of our genetic code. You're probably a pretty big fan of DNA, deoxyribonucleic acid. It could not have existed without its counterpart buddy, ribonucleic acid, or RNA. In fact, that stuff was so dang successful, it is still in our cells today. It's the helper maker of proteins. It cooks up, it reads your DNA. It is the stuff that makes up these little molecules called ribosomes, which any protein you have ever made in your body ever was thanks to little clumps of RNA just doing their business in your cells. But DNA and RNA were not the only forms of genetic information that were likely to have evolved in the early Earth. In fact, our planet likely cycled through 6 different methods of genetic storage before DNA became the dominant species, I suppose. We had threose nucleic acid, peptide nucleic acid, hexose nucleic acid, glyconucleic acid. I would not want to be memorizing all those acronyms, like LOL, PNA, TNA, HNA, TMI, too much information. Anyway, the point is, there are so many ways to encode information in a repeating chain molecule like DNA. It is not necessarily that there's anything special about ribonucleic acid or deoxyribonucleic acid. It's just that happened to be the most abundant supply in the early Earth. But really, if you have these molecules on the surfaces of planets across the universe with similar conditions, you could imagine these things evolving. And this is the kind of convergent evolution that I want to be getting at. This is sheer speculation, of course, but just take a moment to imagine the kinds of common features that could be evolving across the universe at this very moment, just because of the basis of common chemistry that we all share. And of course, life did pick up a lot of common features from other forms of life, thanks to a sort of FedEx delivery service between forms of life, also known as retroviruses. Actually, viruses at large do this, but retroviruses are the main culprit. For the record, retroviruses are a little different from normal viruses. Your good friend COVID is a normal virus. It breaks into your cells, shoots its DNA in, a bunch of swarms of molecules copy the DNA, it explodes, a bunch of viruses are made, and the cell dies, and then things start getting bad. Retroviruses, they're a little more sneaky. They go into your cells, and then they inject their genetic code, and then they stitch the genetic code into your own genetic code in the cell, and then their genetic code just sits in your DNA until either one day that DNA gets copied and then it explodes into a virus army, and that's bad, and that's usually what causes HIV, or it just sits there and does nothing. And for most species of retrovirus, it does nothing. In fact, throughout history of all the billions of species of retroviruses, some of them have even been beneficial. About 1.6 billion years ago, some retrovirus just delivered this molecule called HAP2, which, for the record, is a sort of key that lets cells bloop into other cells. So it lets 2 cells with 2 different bubble membranes bloop into each other. And right off the bat, right there, reproduction was possible. Because how else are you supposed to fuse 2 gametes? And then all of a sudden, cells started blooping into other cells galore. This did not just happen once throughout history. This happened at least 25 times. So again, convergent evolution, another common trait between life across this planet, is the ability to bloop inside other cells and team up on a cell-wide level. So this is where your classic meme mitochondria, the powerhouse of the cell, came from. Mitochondria, eukaryotic cells, both doing their own thing, both free-swimming organisms, and then HAP2 comes along and is like, we're going to bloop you together. And they have been locked lovers ever since. Then, of course, multicellularity, like I said, 25 times independently. This is not a one-off event. But the reason this was so popular is because life, being forged off of chemicals operating together, really had a common thread with teenagers today, which is that they will absolutely crack and bend under peer pressure. As in, if you have just a normal developed cell and you give it a certain chemical, it will shut down all its genes except for the ones that make it specialize into various roles. So if you give a stem cell, or like an undeveloped cell, a bunch of different chemicals, you can turn it into just about anything. And then it starts secreting the same chemical out to the cells around it. And it's basically just this really sly cellular way of saying, it's kind of cool, you should try it too. Like, don't even worry what your parents think, they were you. Anyway, and this is why eyes were so popular, because this trait that, retinal, that caused photoreceptor genes to become so common, really was just secreted across the entire planet. And because it gave such a competitive edge to species to survive, seeing really became like a dominant trait across the world. But this is the weirdest bit, because even brains, something which we think is like indescribably ours. This is like the crowning achievement of human evolution, except it's not quite just ours. The common theory for a while, until 2013, was that, the main culprits here are 3 species: sponges, jellyfish, and animals, which include us. So the common theory, because sponges kind of look a bit undeveloped compared to animals and jellyfish. So the theory was that sponges probably broke away from our tree of life a lot longer ago than jellyfish. So they did not have brains, and then they broke away, and they still don't have brains today. And then the ancestor of jellyfish and animals probably evolved brains, and that's why jellyfish inherited brains from that ancestor, and we inherited brains from that ancestor. Great. Y'all got that? Yes. Well, that's wrong. New theories from 2013. Perfect, yep. Suggested, because looking at ancient fossils, it seems that jellyfish are a lot older than we thought, a lot older than sea sponges too. And this has forced people to reconsider that perhaps jellyfish actually branched off first, and then this brainless ancestor produced like sea sponges that still have no brains, and then the animals and the jellyfish each had to evolve their brains independently. That is weird. That is really weird. That is like inheriting your family heirloom from your girlfriend's family. Like completely unrelated strains of life, evolving kind of the same thing, which, when you think about it, the fact that this evolved twice on the same planet really does just underscore the power of convergent evolution, the ability for nature to evolve the same traits coincidentally multiple times. We know that from these species from the Cambrian. Again, they all have brains, and yet they're from completely different domains of life. And these things have been around since the beginning of complex life, 500 million years ago, back in the Cambrian days. Cambrian kids, remember. It really is. Okay, the horseshoe crab has not, the reason we know this is because the horseshoe crab has not evolved ever since it first evolved 500 million years ago. It is literally still rocking the same body plan that it did back in the Cambrian. If you compare Cambrian fossils of the horseshoe crab and modern horseshoe crabs, they could literally be brother and sister. Like if I had that much consistency in my schedule, I might actually be doing something productive with my life by this point. It is amazing. So horseshoe crabs, again, this is the reason why we know about this brainy theory. And then again, because so much DNA has been passed back and forth with viruses, because so much DNA has evolved common traits with convergent evolution, I want to just underscore this point. This is kind of the poetry of DNA that I love when I get sentimental and a bit unscientific, which is that all of humans together as a species share 99.92% of our DNA in common. That means strangers, family, friends, partners, 99.92%. That is 1 in 1,300 rungs of DNA difference. 12,099 the same for every one that is different. If that's not unification of a species, I don't know what is. Family reunion right here, I swear. Like, no, seriously, if you do the math, we are all likely to be 50th cousins or closer. Almost guaranteed we all shared a common ancestor within the last 3,400 years. And if you take other species, it's more divergent, but we still share a baffling amount of DNA in common with our closest primates. See, I took one of those online DNA tests, and mine came back 98.4% gorilla. Like, I don't want to ask my parents what they were getting up to, but that's... Anyway, but seriously, if you look at life across the board, there is always some DNA that we share in common, just because cells need the same things to stay alive. Even in the plant kingdom, sometimes over half of the DNA is the same. Yeah, bananas are actually one of the most relatable plants. Even amoebas share a fifth of their DNA with human cells, just because cells need the same things to survive. So I just love appreciating this, because not only does it underscore the common traits that can evolve even in completely different aspects of life, but it also really just unifies us as this one species amongst a vast, like an enormous collection of life. And I want to just talk about one more point. It's almost funny just how human-like some life can be even before humans came along. Now, humans at one point, about 300,000 years ago, existed with 8 other hominid species that were literally almost humans, but could not be considered a human species given the definition of a species, which is more or less something you can breed with and still have successful offspring. So it's honestly like a big theory about why they went extinct is that they tried too much crossbreeding and it didn't work out. But anyway, by the time it was 100,000 years ago, there were really only 2 hominid species left alongside humans, which were the Neanderthals and the Denisovans. Basically almost us, but not technically human yet. And this is really interesting because there have been discoveries in the last 2 decades alone that have really just flipped upside down our perception of what it means to be human. The traits that we think are inherently human are not quite, because in Border Cave, a couple decades ago, they found these bones that had little tick marks etched on it, and they thought, okay, well, this is obviously human ancestors. Psych! No, it's not. As a matter of fact, these are Denisovan fossils from 40,000 years ago, showing evidence of counting, using tick marks, arbitrary symbols, to denote how many of something there is. It seemed to show the cycles of the moon, as a matter of fact. These could be some of the first calendars in the world. And that's not a human creation. These were Denisovans. Jewelry, even. In Grotte de Rennes Cave in 2012, there were fossils discovered in France, basically, from 40,000 years ago, that were not human artistic projects. These were Neanderthal projects that basically comprised of necklaces with bones and teeth, several pigment arts, and that did not show any signs of being like used for a survival advantage. Perfect. Anyway, jewelry not used for a survival advantage, but just because it looks pretty. That is not, as it turns out, an entirely human preference. Neanderthals were getting at this kind of fashion trend idea too. And even burial grounds. This was discovered in Shanidar Cave a couple of years back, 100,000 years ago. They found 10 Neanderthal corpses that showed signs of tribute, basically symbols that had been laid to rest with the dead. The first mourning of the deceased was not a human ritual, but a Neanderthal one. And even, this is the craziest one, sailing. Because a couple years ago, they found Mulsterian rocks. Mulsterian rocks are like these fossil tools that Neanderthals used. Literally only Neanderthals did this. It's like Victorians and dark matter beer. Like if you find dark matter beer, you know that Victorians have been there. If you find Mulsterian rocks, you know that Neanderthals have been there. And they found these on the island of Crete. And nowhere in the climate record of that region has the sea level ever dropped so low that you could just walk there. Crete has been an island for the past few million years at least. And when you think about how much water there is between that, that is 200 kilometers from mainland Greece. You are not swimming there, even on a good day, even if you're buff. Neanderthals, it could have been, there are scenarios that preclude the idea of sailing, like perhaps random driftwood, geological shifts, but all theories point to the idea that Neanderthals, whether on purpose or by accident, floated to Crete 120,000 years ago, which means the first seafaring voyages were not even taken by humans, but by a species that resembled us in almost every way, but were not humans. And if that's not convergent evolution of species from completely different periods of time, but with the same kind of drive, same kind of makeup biologically, same kind of curiosity, if that's not convergent evolution on a really profoundly deep level, I don't know what is. And then, of course, humans did take center stage. We built beer. We built buildings, cities. We discovered the number pi. We sailed the oceans. We invented like mass scale I'm spitballing here, never mind. Okay, the point is we also invented space travel. We also invented telescopes. We peered into the skies and looked at the universe from whence we came. And we discovered worlds beyond our own. In fact, nowadays we have discovered 5,876. In fact, that number's probably gone up since I added it this morning. I don't know, they're finding them all the time. 5,876 confirmed planets beyond our solar system, 55 of which are Earth-like in this really delicate zone called the habitable zone, where liquid water can flow, where it's just the right temperature for water and life as we know it to exist, where the gravity is kind of Earth-like, where the composition of the atmosphere contains water vapor. That could mean anything. It could be sulfuric acid and water vapor for all we know. But like, let's take the benefit of the doubt here for a moment. 55 Earth-like planets, 55 chances for all the crazy coincidences of Earth to happen again somewhere else in the universe. And if we keep on listening, we've had the SETI, the Search for Extraterrestrial Intelligence, listening since 1982. And if one day we find a hydrogen symbol, or the digits of pi encoded in binary, or even just a random string of dits and dashes. What did I just say there? Dots and dashes. God, I need a chocolate. Let me try that again. Yeah, if we find any of these, it could be random radio noise from space, but it also could be some curious fellow out there in space making a really, really hard effort to say, hey. All right, I'm Nathan Hellner-Mestelman. Thank you so much. I will be signing books out in the foyer. If you have any questions, shout them out. I will try my best to answer. Thank you so much.